This video is going to talk about graphing rational functions. I'm going to try to keep it really simple to the two forms that are basic hyperbolas that create basic hyperbolas, which is what we call the shape that a basic rational function will make. And so here's what I'm going to give you. The two forms I'm going to graph so that you can decide whether you want to watch this video or not are going to be y equals a over x minus h plus k. And then the other one is going to be y equals a x plus b over cx plus d. So I'm going to try to graph both of these and break each form down, and then hopefully we'll see what a normal basic rational function looks like. So let's start with this one. So that first form, if you've been in an algebra class long enough, you'll have seen formulas where they use a, h, and k to represent transformations of functions. So they still do all the same things, but I'm going to focus on h and k. So in a rational function, you have a vertical asymptote, and that vertical asymptote is always going to be at x equals h, or another way of saying it is the x value that makes the denominator equal 0. So we're going to look for our vertical asymptotes and find when those when the denominator equals 0. The second thing is a horizontal asymptote, and sometimes teachers will have you kind of discover and find where the horizontal asymptote is. You can assume that the horizontal asymptote, I'll just be very brief with it, the horizontal asymptote is at y equals 0 in this form, unless there is a vertical shift. And if there is a vertical shift, then it's going to be at y equals k. So it's either at y equals 0 if there is no vertical shift, or it's at y equals k. So it moves from 0 up or down to whatever that value is. All right. So let's try to graph one. That's the basic kind of gist of that form, and so we'll see how that works for us. Let's move this down a little bit, and let's try one out. So y equals let's just go with 1 over x plus 1 and then minus 2. All right, so the first thing I'll look for is I'm going to look for the vertical asymptote, and all I'm going to ask is I'm going to look down at the denominator, and I'm going to say when does the denominator equal 0, and that would be at x equals -1. And so at -1 on the x-axis, I'm going to draw in my vertical asymptote. So I use dotted lines in order to do that. And it's going to be really important that you draw in your asymptotes so that you can actually use the asymptotes to help guide you in making a nice graph. Then the next one, horizontal asymptotes. So once again, it's normally at y equals 0 for this form, but since there's a shift down to, right, that's what this is saying over here, -2 at the end, so it's going to be at y equals -2. So at y equals -2, I'm going to draw a horizontal asymptote on my graph. And now you may have a teacher like me who says you can use a calculator sometimes, and then other times you can't. So since I don't have a calculator sitting next to me at the moment, looks like we're going to go by hand. And so I ask students to do it both ways, which is good. You should know how to graph without a calculator. If you're going to graph without a calculator or with a calculator, it doesn't matter. Here's how I would look for points. I'm going to look for points to the left and to the right of the vertical asymptote. So to the left of the vertical asymptote would be x values like -2 and -3. To the right of the vertical asymptote, you'd see x values of 0 and 1. And so I find that those are easiest to plug in, and you plug those in and you should be able to find your graph. So when I plug in -2 for x, -2 plus 1 is -1. So 1 divided by -1 is -1. And then -2 is -3. So I'll have a point at -2, -3. There it is. And then plug in -3. -3 plus 1 is -2. That's -1/2. And then -1/2 minus 2 is -2.5. So I'm going to go to -3 and then just kind of in the middle there. Alright, plug in 0. 0 plus 1 is 1. 1 divided by 1 is 1. 1 minus 2 is -1. So now I have 1 at 0, -1. And then I plug in 1. 1 plus 1 is 2. So 1 divided by 2 is 1/2. 1/2 minus 2 is -1.5. And so then I have 1 at 1, -1.5. So if you've never seen these graphs, then you have no clue what to draw. And so here's what you're going to do. Is a hyperbola is two branches. It approaches both asymptotes, and so therefore it curves down and kind of nestles right in between those asymptotes. And so you have two branches, one right there and one right there, and that is the graph. It looks just like that, and it's a basic hyperbola, and that is the simple graph of a rational function. If your teacher is asking you to do the domain and range, there's multiple ways you could do it, but here's one way that I'll suggest. The domain, if you notice, the graph goes to the left and to the right, but it just doesn't use the x value of -1. So I'm going to say that x can't equal -1. And by saying x can't equal -1, I'm saying x can also be everything else. The range, if you look at that, the graph goes down as well as it goes up. It uses all the y values except 1. That'd be -2, where the asymptote is. So I'm going to say that y can't equal -2. And in doing that, I'm saying that the y values can be anything else, everything except -2. Alright, so that's the first formula. Let's try and see if we can't get the second formula in here. The second formula has some similarities. The graph should be the same for sure. But then the second similarity is you find the vertical asymptote the same. So I'll write the form again. It was y equals ax plus b over cx plus d. So to find the vertical asymptote, look at the denominator. So to find the vertical asymptote, you're going to find when the denominator equals 0. So you'll just have to solve it. Then for the horizontal asymptote, it's actually a rule. I don't have time to explain it on this video, or else then it gets a little long, but the way to find the horizontal asymptote is as follows. You are going to actually do the ratio of the numerator and the denominator, their coefficients. So the horizontal asymptote, whoops, don't need that. The horizontal asymptote is going to be found by doing this. Y equals A divided by C. So here's your leading coefficient of the numerator and the leading coefficient of the denominator. You are going to find the horizontal asymptote by just dividing the two numbers. So whatever number you get, that's going to be where your horizontal asymptote is. So A divided by C. Alright? So let's see if I can make one up, and maybe we'll graph it. We'll see how it goes. Maybe. Oh, that got big. Dang. Alright. So here we go. That's crooked. That's going to bother me, isn't it? Oh, is that still crooked? Do you know if it's crooked? My cat can't tell me if it's crooked or not. Okay, whatever. Alright, so here we go. Y equals, let's go with 2x plus 1 over x minus 3. So, let's ask the first question. Where's the vertical asymptote? Right? That's going to be the denominator. And so, what makes the denominator equal 0? it's going to be x minus 3. So, or positive 3. So x would equal 3. All right. Then let's go with the horizontal asymptote. Remember, the horizontal asymptote is going to be found by a divided by c. So take a look at the leading coefficients. You've got a 2 on top, and you've got a 1 on the bottom. So 2 divided by 1 is 2. So y equals 2. So I'm going to draw in my asymptotes, right? So x equals 3 would be my first asymptote, and y equals 2 will be my second asymptote. And then you are going to just plug in numbers. Once again, like I said, if you plug in two x values to the left and to the right of the vertical asymptote, you'll find semi-decent numbers. So to the left would be like 2 and 1, and to the right would be 4 and 5. And so if you plug those in, you may find a little bit more success. So 2 times 2 is 4, plus 1 is 5, and then 2 minus 3 is negative 1, so 5 divided by negative 1 is negative 5. And then when I plug in 1, 2 times 1 is 2, plus 1 is 3, 1 minus 3 is negative 2, so 3 over negative 2 is negative 1.5. Plug in 4, that gets me 8, 9, divided by 1 is 9. And then plug in 5, you're going to get 10, 11 over 2. 11 over 2 is what, 5.5. And so now it's time to plot those points. So 2, negative 5, and then 1 and negative 1.5. And I don't know, maybe it's hard to tell where it would be next. Plug in 0, I'd get negative 1/3. So it would be like right there. And it's going to do the same kind of shape as we saw before. Just a little bit more spread out. So you just kind of curve it, follow it along. You know it has to approach the asymptotes. It can't go away from the asymptotes. So that's where the graph has to go. 4, we got 9. That kind of goes off my graph, but we'll put it right there. 5, got 5.5. Put it right there. Let's see what happens when I plug in 6. 6, 12 plus 1 is 13. Divided by 3. That's like 4 1/3. So about right there. I guess it's as good as it's going to get. And just know it has to approach the asymptote. So gently follow the curve as it goes that way. If you wanted to do the domain and range, the domain would be x can't equal 3. And the range would be y can't equal 2. Alright, so that's kind of the breakdown of each form. Hopefully it makes sense, and I hope you have a good day. Alright, bye.